this session we will learn about vector. What is vector? What is vector, and we will go what is the component of vector, what is addition and subtraction of vectors, what is multiplication of vectors. First of all, vector. What is vector? Vector is a quantity which has got magnitude and direction. Direction is very important. Plenty of things have magnitude, weight, kg, 5 kg. It has got magnitude. It doesn't have any direction. Okay. Now velocity. Velocity we call, suppose let's say this is initial and final point of vector. This is how we represent a vector. This is the magnitude of vector A is this is the magnitude and this is the direction. Now this vector has certain direction. It's not that this vector is going in this direction or any other direction. This has got fixed direction. So that's why we call it a vector. It has got certain direction. That's why this direction is most important part. We will now another point here is we will learn about x-axis and y-axis. Just give a brief idea about what is x-axis and y-axis. It's a two-dimensional figure. Here we call it x-axis and we call it y-axis. Okay. Now, this we cover in two-dimensional 360 degree. Now, any vector will have certain direction with x-axis and y-axis in any direction. You will have certain. Suppose this is a vector. This is a vector because it has got certain direction and certain magnitude. Put an arrow over every vector to show that it's a vector. Now, what are vectors? Now, suppose distance. We say distance is not a vector. Why? Distance we say 5 km. Now 5 km can be in any direction. It can be in north direction. It can be in south direction. Now we say this truck. One truck is moving in with speed of 10 km per hour. Now 10 km per hour can be in any direction, right? We cannot say, so that's why we cannot, this 10 km per hour is the magnitude. But do we have any direction? No, we don't have any direction, so we cannot call it vector. Now, when we say 10 km per hour with an angle of 45 degree with x-axis. Right, then it becomes a vector. Why a vector? Because it has got magnitude and it has got direction. And this speed is called velocity. When we have speed, magnitude and direction, we call it velocity. And velocity is what is velocity now? Velocity is vector. Okay, why? Because it has got magnitude plus direction. So whenever you say velocity, it means it will always have a direction associated with. हमेशा इसके साथ एक डायरेक्शन होगा. If you don't have any direction with it, you cannot call it vector. Now what is the use of this vector? Whole physics, while studying whole physics, you will find the plenty use of vector. Everywhere, because not only we are interested in magnitude, we are interested in direction. We will see when we will add, subtract and multiply vectors, plenty of different phenomena are generated. That's why this vector is very important, and this is very basic chapter actually. You don't have to worry too much. You just give yourself some time to absorb these things. Once you go over the next chapters, and after 2-3 chapters, you will find the vector. It becomes inside your blood. It becomes very easy. It's a very easy and basic topic. So you don't have to worry too much. What is so many things? associated with it. It's a very easy and simple topic. Now we have seen it in x-axis and y-axis. Normally we x-axis and y-axis. We describe normally a vector this way. Now y we will write vector A. Okay. A certain direction, say angle theta. Okay. Now what happens? Suppose a car moves in this direction. Okay. At the speed of 10 km per hour. Right? 10 km per hour, angle 45 degree again. Let's say 45 degree. Okay, so and the car moves for 2 hours. Let's say 2 hour car moves. What will happen? After 1 hour, it will cover a distance of 10 km. After 2 hours, it will cover a distance of total 20 km in this direction. Right? So what happened? The car has moved from this point to this point. But what we can say, we draw a perpendicular from this point to here. Similarly, we draw a perpendicular from this point to here. Okay, we draw a perpendicular. Now, this component is x component. This is called y component. Okay. What happened? What has happened? The car has moved from this point to this point, right? It means the car actually in x-axis direction, it has moved up to this point only. In y direction, it has moved to this point only. Not completely, because of this direction, because it has got, this is a vector. So what we do, we want to know how much exactly it has come to this point. We will break this, we make it a component. Have you gone through this triangle? This is theta, this is base, this is height, and this is so sine theta equal to h by p, and cos theta equal to d by p. Okay, right? So same principle, we use it this way. How much is the x component? X component equal to, this is a, so magnitude of a cos theta, and y component will become sin theta. Okay, so using whichever this angle, you use it to draw this way. This is cos theta, and if you go in opposite direction of this angle, because this angle is 90 degree, right? This one becomes 90 minus theta. So we call it sin, this cos theta, this sin theta. So you get the exactly value of x component and y component. So anytime you will come to know how much it has moved in x direction and how much it has moved in y direction. I will just give you a simple example how we use it. Suppose you are standing on this. Suppose this duster is here. Now I throw it. What will happen? At full speed, we call it velocity. It's in such a way that its speed velocity is constant and it moves in straight direction. Now what happens? This will move and go down, right? It will touch to the earth because force gravity is acting below. We will go in detail in different chapters. Just want to say that. Now what happens? It comes to still. So what we do? What we know? If velocity was this, So there is one force was acting down. What was happening? One velocity was moving in this direction. One force was acting in this direction. So resultant was in this direction. That's why this duster from, if we throw it goes down and touches the earth. And with this principle, what can we do? We can find how much the bottom distance it has gone and the horizontal distance. We will use all these things in different chapters. Just now we concentrate. We will learn here how to break it in a vector in component. Very important. We will go back again what is vector and how we break it in a component. Okay. Vector is a quantity which has got magnitude and direction. Direction very important. Okay. Without direction, no quantity can become a vector. Okay. Now vector has got certain direction. For few chapters, we will go for only 2 dimensions, x, y. Actually, we have 3 dimensions. Okay, x dimension, y dimension, and z dimension. But instead of going in all those details and making it complicated, we will go for 2 dimensions right now to understand vector and make it simple. X-axis and y-axis. When we have a vector in different direction, we break it into 2 components, x component and y component. Okay, and we use the simple triangular formula to find what is the x component and what is the y component. Okay. See, say this distance is x, okay, and this one is a, which I have shown. So cos theta equal to this magnitude a, we express magnitude a divided by x. Sorry, I wrote opposite. X divided by magnitude a, right? Because this is the hypotenuse and this is the base. Cos theta equal to. This implies x equal to, what will happen? This will go to here. A will multiply to magnitude a multiplied by cos theta. Okay. Similarly, you can go for the y. Okay. So it will come to this way. Always use this way. This is your vector. Theta is this. So this component always a cos theta. Since theta is this will go to y sin theta. Sorry, a sin theta. Okay, a cos theta, a sin theta. This breaking of this vectors you will find plenty of use it throughout physics. You will use it. It's so try to understand it and fill inside your mind that how I will break it very simple. If you see any vectors, suppose this angle is alpha, what we will say, and this one is say a, magnitude instead of writing so much thing, a. So what will happen this component? A cos alpha. This component a sin alpha. Now this angle is now changed. We change the angle now. Okay. This is 90 degree. Now this angle is alpha. This angle is alpha. Okay. What will happen? This component a cos alpha. This component a sin alpha. So very simple. We are breaking it. We don't have to go every time write all this formula, put the value, and then come to the value. What will we have? What will be the component? Okay. So once you understand this, it becomes very easy. Plenty of forces you will use it during physics. We break plenty of forces in components. Okay. I hope everyone understand now what is vector and what is the components of vector. Very important. Now, we will go for addition and subtraction of vector. Say vector A. Okay. Now, if you shift this vector, it has got certain initial and termination point. Okay. If we shift this same vector with same length and direction, the vector doesn't change. Okay. this is again same A vector, because the length is same, direction is same, only the position has been changed. So even if we change to multiple positions, it will not change. Vector A will remain same. Okay. When we say suppose vector B, we draw a vector B. This is your vector A. This is your vector B. Vector A is moving in direction. Vector B is moving in this direction. Now, what will happen when we add two vectors? We call it resultant vector. Sum of the two vectors will give a resultant vector. Just a simple example. One person is pulling you in this direction. One person is pulling you in this direction. What will happen? You will move in resultant direction. If this one is very strong, you will move little closer to this person. If this person is strong, you will move closer to this person. So similarly, you can understand in this way. What is happening? The two vectors moving in opposite direction, and we have to add it. What we are doing? We are finding a resultant vector. What will happen when two such vectors meet? Where the body will move, where the particle will move. Okay, let's add these two vectors. Say this is vector A, this is vector B. What happened? Now we have to find the resultant vector. What we will do? We will shift this vector to the head of this vector. Okay? We are shifting this vector to head of this vector. Again, the vector is same because the length is same, magnitude is same, and the direction is same. Again, we will shift this vector to this at the head of this B. Again, what will happen? This will become vector A. What is happening? Vector has not changed. Same A, same B. What is? So the two lengths is same. Okay, this length is same. They are parallel to each other. What has become? It has become a parallelogram. What will be the resultant vector? The resultant vector will be this. Diagonal of the vector, the parallelogram becomes the resultant vector. Sum of two vectors. This is your sum of vectors. Okay? So, if you are standing there, one person is pulling you with this force in this direction, another person is pulling you with this force, and in this direction, you will start moving in this direction. This is what exactly it is saying. Okay? Very simple now. Now you understand what is the meaning of adding two vectors. We find resultant vector in which exact direction it will move. How we find the value of A plus B? A plus B equal to mod A. Mod A, it means magnitude of A. Okay? Plus mod B plus 2 mod A mod B plus 2 mod A mod B cos theta, where theta is the angle between the two vectors. Okay, how this formula, or in other way we will write sum of vector A plus vector B equal to A plus B plus 2AB cos theta. Okay, what is happening? How we will derive this formula, how this formula has come. Okay, you don't have to remember, we have to understand how this formula came. Okay, this is B. We will draw the diagram again to make it little large. Okay, and make it little more clear. Okay, this is vector B This is vector A. Right? This is your resultant vector moving in this direction. If this is your angle theta, what happens? Again, we'll break this B into components. What will happen? We will extend it, and what will happen? We have drawn a perpendicular to the base of A. We have extended A, and we have drawn from the head of B to this base. Now this angle and this angle will remain same. Okay, this will again, this angle will be, because this is parallel, this is parallel. This angle is 180 minus theta. Okay, and this angle will become theta because these two are parallel. If someone is cutting it, this angle and this angle remains same. Okay, now what happened? What will happen? This component. Okay, B cos theta, B sin theta. This will become B sin theta. This will become B cos theta. Right? Now what happens? Resultant, how it will be? It's a now see, it's a right angle triangle. Okay, this is your sum of A plus A magnitude of A plus B and cos theta. We again write as A plus B cos theta. Now this length A. Let's say P, Q and R. So this becomes A plus B cos theta, and this का whole square plus B sin theta का whole square. Okay. Now let's see what happens. What we get? A square plus B square. We will first isn't it? A right angle triangle and R. What will happen? The value of now I can see. So what will happen? PR the whole square equal to PQ the whole square plus QR the whole square, right? This is the formula. Or if you remove this square, you put a square root. This is what the same thing here equal to this the whole square plus this the whole square and square root. This is what the same formula I have used it. Okay. Now we will break this square. A square plus B square cos square theta plus 2AB cos theta plus B square sin square theta. Now B square cos square theta, B square sin square theta. Main square root will be A square plus B square cos square theta plus sin square theta plus 2AB cos theta. Okay. Now you will learn, maybe you must be knowing from maths, the value of this is 1. Okay, 1. What it becomes? A square plus B square plus 2AB cos theta. Okay, under square root. This is the resultant magnitude. Right? And this angle alpha. The direction, this is the magnitude of sum of two vectors. What we say? Resultant vector. You know what will be the resultant vector? This will be the magnitude, and direction alpha you can make out, calculate by this component and this force. Got it? Right? So you can now tomorrow if one person is pulling you from in this direction and another person is pulling you in this direction, if you know these two forces, then you can calculate exactly with which speed and in which direction that person will move. This is what is the meaning. I'm just giving you a very basic and simple example. When you will use in practical life, actually in many of instruments, mechanics, even in fans, everywhere this vector is being used. We don't know actually how it is being used. You will learn in the physics next chapters in force and throughout physics this vector we will keep on using it. So you should know very well how to break a component. It's a very important and very easy thing. If you understand thing, always remember draw a perpendicular. Okay. When you have dropped this perpendicular, again similar way, draw a perpendicular. Okay. When you have to draw the perpendicular, this will become, this angle is theta, right? So this one is a cos theta, this one is a sin theta. A cos theta, a sin theta. Okay, this is the component. Very important. Similarly, you can change it. Okay, let's say this angle you don't know, you have this angle. You have this angle as alpha. And what will happen? This component a cos alpha. What will happen? This component a sin alpha. Very simple. I hope everyone can make out a cos alpha, a sin alpha. Okay. Now let's go for multiplication of vectors. Multiplication of vectors, we will not go deep inside multiplication of vectors because multiplication of vectors will go in, actually we use in electricity too much. What happens? Okay, I forgot to tell you the subtraction of vectors. How we make subtraction of vectors? Subtraction of vector is nothing but, say this is vector A. Okay. What will be the negative of this vector? The magnitude will remain same. Only the direction will change. This is negative of this vector. Okay. When we say A minus B, subtraction of this vector, what exactly we are doing? We are adding two vectors. That vectors are vector A plus negative of vector B. Okay. This is exactly what we are doing. Now we'll go back to the same previous example. वापस last example पे ही same use करेंगे. How we are subtracting two vectors. Say this vector again is A. So this is A vector. Again this vector is B. Okay, this is your B vector. Now we have to subtract these two vectors. What will happen? This vector negative, it will reverse, right? Say we will first draw here only. This vector become minus B, right? The direction is exactly reversed. The magnitude has remained same. Now what will happen? We will shift this vector to this point for simplification in calculation. Okay, we shift this vector in this direction. What has become this? Minus B. Okay. Now minus B. What we will do? This is theta. Say we will say call it. This one call it alpha. Now what will happen? The resultant vector. Resultant vector will be in this direction. Okay. We again we do the same thing. Draw the parallelogram and calculate the resultant vector. Okay. Again, the magnitude will remain same. This will become A minus B. This is the resultant vector. Very simple. We have just used the negative, and rest of theory is same. The way we use add two vectors. Similarly, you have just subtracted two vectors. Okay, there is no difference between addition and subtraction. Not much actually. Technically, you are just reversing that vector by using the minus b, and then you are adding two vectors which are of A and this new vector, right? Just the direction has changed, magnitude has remained the same. Same addition and subtraction completed. Now we will go for the multiplication of two vectors. What is the we write vector A multiplied by vector B. This is your vector again A. This is your vector B. This I will change for sake of clarity. Vector A here, vector B here. Okay. The value, say angle is theta. Vector A into E becomes magnitude of A, okay, magnitude of E into cos theta, where theta is the angle between two vectors. This is the magnitude of multiplying two vectors. Now you will say, now multiplying two vectors, what will happen in the resultant? Again the resultant will be a vector. Now when you say vector, this is the magnitude, where is the direction? Okay. Now you know what happens when you multiply two vectors. The resultant vector will be in, we give this way. In three dimensional, this becomes three dimensional figure. This is your A vector, this is your B vector. When you multiply these two vectors, this will be the resultant magnitude, and the direction will be in this direction. Okay? Okay. Don't confuse too much. We will go in detail when you get familiar with vectors, when you feel comfortable with vectors. After 2-3 chapters, you will see vectors is nothing big too much. Like abhi kya 2 plus 2 becomes very easy. 2 into 12. If I ask you 2 into 12, what can you answer it? Easy. 2 into 224. Why? Because you are very familiar with those multiplications. Similarly, these are very basic things. After some times you will find it very easy to say what will be the addition, subtraction, or to break it into components. This becomes very easy. So don't take it tension. Take it very lightly. It's a very easy chapter. You have to just absorb things. What is the addition? What is the subtraction? Always remember, when you add two vectors, subtract two vectors, multiply two vectors, always resultant will be a vector. Okay, and if you say vector, it means it will always have a magnitude and it will always have a direction. So you have to know in which direction the resultant vector is working and what will be the magnitude. That's all. So with this, we will finish this session and we will continue with the another session. Thank you.